In this tutorial series, we are going to create a grid placement system in Unity where we can place objects on the grid as well as remove them if we need to. Hi, I'm Peter and welcome to Sunny Valley Studio Tutorials. In this first video, we will learn how we can convert mouse position to a grid coordinate system so that we can select a specific cell. If you want to follow along, I have prepared a starter project that you can grab using the link in the description. Just unpack the zip file into a separate folder and use the open functionality of Unity Hub. Otherwise, create a new project and be sure to select the URP 3D project as a base for the Unity package that you will import there. When you have the project downloaded, be sure to go to the Projects tab, Assets, Scenes, and open the Grid Placement scene, and here we are going to be creating our grid placement logic. In our project, we have this grass plane that we are going to be using for our placement system. So the first thing that we need is to detect where are we pointing using our mouse at this plane, what is the position. So let's go to our Assets Scripts folder and I will create a new C# script called Input Manager. And let's open it up. Okay, we're going to have three fields here. A serialized field, private camera, scene camera, so that we can raycast and detect our mouse position. Private vector 3 last position, so that we can cache the last position detected. And we are going to have a serialized field, private layer mask, placement layer mask, so that we can decide which plane takes part in our input detection of the mouse position on our plane. We are going to create one method called public vector 3 get selected map position. So here we are going to get a vector 3 mouse pos equals input.mouse position. We are using the old input system, and we are going to set mouse position.z equals scene camera.near clip plane so that we cannot select objects that are not rendered by the camera. Next, we are going to create array. Ray equals scene camera. That's why we need the reference. Screen point to ray. And we are going to create a screen point to ray from the mouse position. When we have it, we are going to create a raycast hit. This is the result. And we are going to use physics.raycast to detect the selected position on our plane. So we're going to check if physics.raycast and we are going to pass the ray out hit. So the result, we are going to pass 100 as the length of our raycast, and we are going to use the placement layer mask to detect only the plane that we want to use as a grid. We are going to cache this as the last position equals hit.point if this is correct. If not, we are going to simply return the default value, so vector 3.0. This will help us to return some value even though we are pointing our mouse cursor over something else that is not on our layer mask. Okay, let's save the script. Let's go back to Unity. Now there will be a GitHub link to the scripts if you need some help with those. So to use this, we are going to need to have another script called placement system. So let's right click, create a new C# script. We're going to call it placement system. And let's open this script up. We are creating a new script to keep our code nice and tidy. We are going to create a serialized field attribute. And we are going to create a game object, but it will be called mouse indicator. We are going to use it to visualize which position on the plane we are selecting. Next, we are going to have a serialized field and we are going to create private input manager. We are going to need it, so input manager. And we can add private field in front of the game object just for the sake of consistency. Next, we need to have update method and we are going to call here vector 3 mouse position equals, and we are going to call input manager.get selected position. And next we are going to call mouse indicator transfer position equals mouse position. Okay, let's save the script. Let's go back to Unity. Great. In our hierarchy, we have this building system parent game object. Let's right click on it and create an empty object, and let's Ctrl D to duplicate it. First one we are going to rename to be input manager. And the second one will be placement system. Okay, we are also going to add here, right click and add a 3D object sphere. This will be our temporary mouse pointer. Let's select in the inspector its scale. Let's toggle uniform scaling and let's scale it by 0.2. So this will be the scale so we can see this object, but it doesn't take the whole cell space. Onto the input manager, we are going to drag the input manager script, and we are going to assign to it the screen camera. So in general objects, we have this main camera object. Let's assign it. For the placement layer, we can for now select the default layer, since this is the layer on which the grass plane is right now. We are going to modify it later. Okay, we have everything for the input manager. For the placement system, let's drag the placement system script, and we need to assign the mouse indicator. So this is our sphere, and the input manager, this is our input manager. Let's select our sphere, and let's set its layer to be, for example, water, so that our detection system does not detect the sphere itself. Okay, I think we are good, so let's press play. Okay, great, and now you should see that our sphere is following our mouse pointer, so that's great. We have the input detection on the plane. Now we need to find the cells that are assigned to each piece of land on our plane, and we can create this grid placement system. To easily convert our world position to grid space, we are going to use the grid component. It is a guide that helps us align game objects such as tiles based on a selected layout. And if we go to the switch to scripts, we're going to find that it has two important methods: cell to world, which converts a cell position to world position, and world to cell, which converts the world position to cell position, so we can easily convert our position using this component. If you are enjoying this video so far, it would really help me if you would click the like button or post a simple comment like thanks right now under the video. It really helps with the YouTube algorithm. In our project, let's go to the hierarchy building system. Let's right click and create a new empty game object. We're going to call it grid parent. I'm going to explain why in a bit, but the important part is that we place our grid inside this. So we are going to right click, create an empty object. We are going to call it grid. And we are going to add a component, and we are going to search for the grid, and here it is. Here we can set the cell size on the X, Y, and Z. 1 is optimal, since it represents 1 unity unit. So if we add a 3D cube, this is 1 unity unit. The size of the cube is 1 unity unit. Okay, and we can modify the cell layout to be hexagonal if we want to. We are going to leave it as rectangular. With this done, we are going to want to modify our placement system script. Before we go and do that, we need to find in the prefabs folder inside our projects tab, we have those different prefabs. Here we have the cursor indicator parent. We are going to use it to indicate where is our grid cell, because right now we can't really display our grid on top of our plane, so we are going to use this. So let's drag it into our building system for now, and this will be representing our object on the grid. Right now this is Z fighting with the grass plane, so let's select the child object of this, and we are going to set the Y position of this to be 0.05, for example. So now we can display it on top of our grass plane. Great, so now everything is prepared. Let's go to our scripts and let's open our placement system. Great, here we are going to add another game object reference. This will be our cell indicator. And obviously we need to add a serialized field. This will be a reference to our grid, so private grid grid. Inside our update function, we are going to now convert the mouse position to the grid space. So we are going to create vector3 int grid position, and we are going to set it to be equal to our grid, and we are going to convert world to cell. This converts a world position to cell position. We are going to pass to it a mouse position, and we would use it to save data about our grid, but for now we are going to create another line, cell indicator transform position. We're going to move it to our grid cell to world. We're going to select this method, converting the grid position back to world position, but now it is the cell position and not the mouse position of our cursor. So let's save this, and now let's go back to Unity. Great, let's select our placement system in the hierarchy, and let's assign our grid to where the grid reference is, and our cursor indicator parent where is the cell indicator. Now we should be good to go, so let's press play. Okay, and now we should see that the cell cursor or cell indicator is not moving with our mouse position. Only when we move to the next cell it is being moved, And now we can see where are the cells and where is our mouse pointer. So if we are selecting position within this cell, we're going to select only this cell. If we go to the right or to the left or wherever, we are going to select the next cell. And this is how we can create a simple grid placement selection. One thing that I want to point out is that if we select our cursor indicator parent, we are going to see that it has its pivot point in the bottom left corner. So this is how our cells are represented inside our grid. So they are represented as the bottom left corner. So if you have an object that has a pivot point in the center, you need to calculate this position based on the grid cell size. Just to explain why we need this grid inside the grid parent object, if I leave the indicator somewhere on in our game and I will select the grid parent in our hierarchy and start moving it, you will see that now the cell position is being updated for our grid indicator. So basically we can adjust our offset of our grid by moving the parent of our grid, which can be useful if we want to move our grid. If I set the position to be 0 and 0, and if my grass plane is at 0, 0, as you can see, the position that we have selected is adjusted to the default grid that Unity presents us in every project. This is because the center of the plane is at 0, 0, 0 and the grid is placed at 0, 0, 0, so it starts selecting the positions with the layout of the default grid inside Unity. It is pretty important when we want to move our grid to some other position on our map. In the next video, I want to create this grid overlay using a custom shader so that we can see where are the grid cells on our grass plane. If you want to learn how to use this grid placement system in a more advanced house building project, I have this house building system Unity project template. The link will be in the description if you want to check that out. Okay, see you in part 2 of this tutorial.